Hello everyone, this is a quick review for matrices. I will go from your Algebra 2 book, lessons 3.5 until 3.8. So far what we've seen in your تحصيلي test were all simple operations, multiplication, addition, or about inverses. Not much of complicated matrices. Anyways, lesson 3.5 was introducing what is a matrix, and that a matrix is written this way, and for example the numbers are written in this form, and then the matrix dimensions are always written rows by columns. So this is, for example, 2 rows. Let me add here, this is 2 rows by 3 columns, so the dimensions of this matrix is 2 by 3. And we can multiply multiplication by a scalar. If I have 2 multiplied by a matrix 1 2 3 1, for example, this is called scalar multiplication. And I will just distribute the 2 on all of them, and I will get 2 4 6 2. For example, double the matrix, and this is called it was written like this in your book, KA is equal to KA. Anyways, and we have addition. We can only add and subtract matrices if they have the same dimensions, as you know. For example, 2 1 2 2 plus, for example, let's say 1 0 0 1, whatever. Okay, they have same dimensions because this is 2 by 2 and this is 2 by 2, and you will add corresponding elements. 2 plus 0 is 2, 1 plus 1 is 2, 2 plus 0 is 2, 2 plus 1 is 3. You can add and subtract, and there's no problem with this part, I think so. In lesson 3.6, multiplying matrices multiplying matrices was a little bit harder. As we know, we always go by rows, by columns. To be able to remind you how to be able to multiply matrices, the dimensions, for example, 2 by 3 and 3 by 6, these two matrices can be multiplied by each other. Why? Because the columns of the first one is the same as the rows of the second one, and your answer will be a 2 by 6 matrix. Remember when I used to cancel this with this? And this is a 2 by 6 matrix. For example, I have a 2 by 1 and I want to multiply it by a 2 by 1. That's impossible, because these two numbers are not equal to each other. Okay, I will remind you about before I proceed. For example, 2 1 3 4 2 6. Let's say this is matrix A and I want A2 1. What do they mean by A2 1? Means they want the member, the element of this matrix which is in the second row in the first column. So in the second row, this row, and in the first column, the answer is 4. Okay, in case, because I saw this once in your tests. How to multiply matrices? Okay, if I have, for example, a 2 by 2 multiplied by a 2 by 2, okay, I would go always rows by columns, and my answer, if I cancel this with this, should be also a 2 by 2. Let me just pick easy numbers for now. Let's say here 1 2, let's say 3 and 0. Okay, I will always start by row. First row with first column would give me the first number, and whatever that's between them we add. 2 by 1 plus 1 by 3, and that's a 2 plus 3, which is 5. This is the first number. To get the number at the right of it, I would do this row with this column. Okay, so 2 by 2 plus 1 by 0, which is 4. This is the 4. Then I usually go finish the first row with this column and with this column, and then I move to the second row. Second row would give me these answers. Okay, second row with the first column, 0 by 1 is 0, 0 by 1 plus 1 by 3, and that gave me 3. I would write the 3 here, and then I'll move to the coming column. 0 by 2 plus 1 by 0, it's a 0, and here is the answer. This is how to multiply. Let's say I have another matrix that's, let's say, 3 by 1, and here it's 1 by 2. Okay, that's possible. 3 rows by 1 column, so let's say 1 2 3. Okay, here I have 3 rows and 1 column, and the other one is 1 row by 2 columns, so let me say 1 2. Okay, that 1 row by 2 columns. I'm expecting the answer to be 3 rows by 2 columns. Okay, so I have 1 2 3 4 5 6 numbers to get. Now I will start first row with first column. I have no addition, just 1 by 1, and that gave me 1. And first row by second column, that gave me 2. I have no addition. Okay, so here 2 by 1 gave me 2, and 2 by 2 gave me 4. And then let's go to the 3. 3 by 1 gave me 3, and 3 by 2 gave me 6, and I'm done. Somehow, if you have matrices, as we said, for example 3 by 2, and you want to multiply it by 6 by 2, for example, you would just try. That's impossible to do because here the columns are not equal to those rows, so you cannot multiply. My notebook is full. Okay, now regarding multiplication, I'm done, and the next lesson is 3.8. Okay. 3.7, I'm sorry, was about solving system of equations using Kramer's rule. Solving system of equations using Kramer's rule. Okay, they will not ask you in the test to use Kramer's rule because nobody's running after you in this test, and you know you have a multiple choice. You can do substitution, elimination, whatever you wish. Anyways, but at least you must know the rule, and you must know what's a determinant. A determinant for a matrix, for example A, B, C, D. If they want the determinant, they would just write it this way: A, B, C, D. Okay, with like the lines like absolute value. Okay, and the answer is AD minus CB. AD minus CB. Okay, so for example, if I want to get determinant of 4210, for example, I have to start from the upper left down to the right. 4 times 0 minus 2 times 1. So the answer is -2, and this is how you find the determinant. In this lesson, we also got to know how to find determinants of 3 by 3. We can find determinants for square matrices only. Square matrices means 2 by 2, 3 by 3, 4 by 4, and so on. We did 2 by 2 and we did 3 by 3. More than that, we didn't do. The 3 by 3 was the very long, if you need to remember that. Anyways, the rule itself is not written with numbers. Let me say I have 1 0 2 2 1 2 0 1 3, for example, and I want to find the determinant of this. Okay, we would copy the first 2 columns outside again. Okay, this is a 3 by 3 determinant. I'm gonna copy 1 0 2 1 0 1, and then I'm going to do left side multiplications minus right side, and remember there is a minus. Left side multiplications are 1 times 1 times 3 plus 0 times 2 times 0 plus 2 times 2 times 1. So 1 times 1 times 3 is 3 plus 0 times, once you see a 0, it's 0. Khalas. 2 times 2 times 1, 4. So the answer is 12. Minus the right side multiplications, 0 times 2 times 3, that's 0. 1 times 2 times 1, that's 2. 2 times, okay, there's another 0, so the answer is 2. 12 minus 2 is 10, and this is the answer of the determinant, 10. This is how to get determinant of a 3 by 3. In this lesson also there is a rule that helps you get the area of a triangle if you have only the 3 coordinates vertices. And if you have the 3 vertices and you don't know the length, okay, the area, let's say this is AB and this is CD and this is EF, whatever the numbers, okay, the area is half, and then I'm gonna put AB and then put CD and then use EF, for example. And over here, how will I make it a 3 by 3? I'm just gonna add 1, 1, 1. And this is the rule that's written in your book. How will you find, remember it has a half over here, how will you find the determinant? Like any 3 by 3, you're gonna copy these two outside here, A, B, C, D, E, F, and then start the left multiplications minus the right multiplications, and your answer has to be divided by 2. That's what's extra, because it's area of a triangle. I'm not going to apply on that, at least know the rule, okay? Regarding Kramer's rule to solve equations. For example, I have a system of equations, ax plus by equals to m, and I have fx plus gy equals to n, and I want to use, let's say, Kramer's rule to find x and y. Okay, the first thing you will need the coefficient matrix. Okay, coefficient matrix, these are the coefficients. So coefficient matrix is A, B, F, G. This is called, coefficient matrix. Okay, طيب, how will you find x? If you want to find x, okay, you will use anything that's not over here, and we'll start with mn, determinant of mn, and then beside it b and g, which were with the y, over coefficient matrix. And what is the coefficient determinant? A, B, F, G. And now if you want to find y, you'll put your finger on y and start with here and then answers. Okay, so AF mn all over AB FG. This will help you find x and will help you find y. Okay, we'll not do the 3 by 3 anyways, it's pretty long. I would just write the rule when I come to it. Okay, so let me solve one question on this. For example, they want you to solve let's say 5x minus 6y equals 15 and 3x. Just to let you know, you don't have to solve in the test using Kramer's rule, but I'm just explaining so you get used to the rule. If you want to find x, you will use the answers first, 15, negative 29, and then the y coefficients over here, over coefficient matrix, which are 5, 3, negative 6, 4. If you want to find y, you will use the x's and then the answers. The x's are 5, 3, 15, negative 29. And then over here, coefficient matrix. Coefficient matrix is written like this, coefficient matrix, okay? So how will you calculate this? 15 times 4 minus, okay, 15 times 4 minus negative 29 times negative 6. And that was going to give you, in the end, 60. 15 times 4 is 60, minus, these will end up in a positive 174, divided by 20 minus negative 18, so 20 plus 18. And the answer is negative 3. If you want to find the y, again, I know down there it's 20 plus 18, خلاص, or 38. And up here 5 times negative 29, which is negative 145, minus 15 times 3, which is 45. And your final answer will be negative 5, and you can check. This is how to use Kramer's rule to solve system of equations. So mainly know the rule. And for Kramer's rule for 3 dimensions, Kramer's rule for 3 by 3, okay, whatever, a system of 3 equations, for 3 equations يعني. Okay, let's say I have an equation, it's almost the same, but I'm going to add z to it. Plus cz equals to m. fx plus gy plus hz equals to n. And jx plus ky plus lz equals to p. Now what's extra here is just those z's. I'm gonna follow same things, but I need to add z to my rows. The coefficient matrix is going to be, or coefficient determinant is going to be afj bgk chl, right? How will I find x? Again, if I want to find x, I'll put my finger on x, start with the answers, go to y, and then add z. So the rule is m and p, and then I'll go to y's, b, g, k, and then c, h, l, all over coefficient matrix. Okay? And if you want to find any coefficient matrix, if you want to find y, put your finger on y, start with x, and then the answers, and then put the z. So a, f, j, m, n, p, and then put the z here, c, h, l, all over coefficient matrix. Okay, what about the z? If you want to find the z, you would just go for x and y and then the answers. So over here, the order is a, f, j, b, g, k, and then m and p over coefficient matrix. And we were supposed to do 3 by 3 determinant, left, right, and left, right, and all of that. It's kind of impossible in your test. Anyways, for lesson 3.8, they started talking about inverses. If you remember how to get an inverse, lesson 3.8, solving again system of equations, system of equations using inverse matrices. Inverse matrices. Okay. The first rule over here, or I just have to remind you what is an identity matrix. An identity matrix, as we said before, is a matrix that has 1 in all its diagonals, 0, 0. This is a 2 by 2. I can make a 3 by 3, 1, 1, 1, and 0, 0, 0, 0, 0, 0. I can make a 4 by 4 identity matrix, 1, 2, 3, 4, and add zeros wherever there are no ones. Okay, what does the identity matrix do? It does nothing. It's like 1 in normal life. If I take any matrix, for example 2, 1, 3, 2, and I multiply it by identity matrix 1, 0, 0, 1, nothing will happen to it. It will come up the same matrix. Let's try. 2 by 1 is 1. 1 times 0 is nothing, so 2. 2 times 0 is 0. 1 times 1, 2 times 0 is 0, and 1 times 1 is 1, so 1. And then if I go to these, 3 by 1 is 3, and this is 0, that's 3. 3 by 0 is 0. This is what it does. Okay, and I'm the same, nothing happened. This is called an identity matrix. Okay, so identity matrix I. Okay, so another thing, if you want to find inverse of a 2 by 2 matrix, inverse of a 2 by 2 matrix, here is the rule. If I have matrix A, B, C, D, and I want to find a negative 1, how do I find a negative 1? I will put 1 over the determinant, okay, multiplied by these two. They switch places, so D, A, and these two, they change signs and they stay in the same place. If they were positive, they become negative. They were negative, they become positive. So 1 over the determinant in this case is 1 over AD minus BC. And here I have D, negative B, negative C. When does a matrix does not have an inverse? It will not have an inverse if the determinant is equal to 0. If AD minus CB is equal to 0, then it doesn't have an inverse because I cannot divide by 0. For example, they can give you a matrix and tell you what number do I need here. Let's say it's 2 by 1. Let's say 2, here's a 0 and here's a 1, and they'll tell you what is B that will make this matrix does not have an inverse. طيب. So definitely B, if B is equal to 0, then it will not have an inverse. Why? Because I have 2 times 0 minus B times 1. This is 0, and if I make this 0 as well, I'll be 0 minus 0. For example, this is just a quick example. You have lots of them in your tests. So I would say B is equal to 0, then there's no inverse. And why there is no inverse? Because determinant is equal to 0. And it's impossible to divide by 0. Okay? I saw this in your tests. طبعا the rule over here says, the rule أصلا it's written where AD minus BC is not equal to 0. Okay, for example, they want us to find the inverse of 7, 2, negative 5, negative 1, and I want to find the inverse. الأول I'm going to get the determinant, and then I'm gonna do the switching of the places and the switching of the signs. Okay, so determinant here is 7 times negative 1 minus negative 5 times 2. This is negative 7 plus 10, so it's negative 3. So negative 1 over 3. Okay, I think I went something wrong. This is negative 7 minus, yeah, sorry, that's a positive 3. So 1 over 3. After that, I would switch places of those two. Here, negative 1, 7. And change signs of those two. Negative 2 and 5. And then I will start doing a scalar multiplication. And the answer will be, sorry, this is a matrix. The answer will be negative 1 over 3, 5 over 3, negative 2 over 3, and 7 over 3. Most probably you will get fractions out of that, okay? Because here I have a fraction. This is the inverse. If this is matrix A, this is the inverse of matrix A, okay? Another thing was writing a matrix equation and all that. I doubt that they will bring, because it's not that simple to tell you to use a matrix equation. Anyways, we just summarize it quickly. Yeah, let's say I have an equation 2y equals to 9, and here I have 3x minus, and I want to solve it using inverse matrices. Okay, the coefficient matrix is x2, 3, negative 6, right? Plus, okay, no, here it's 1, 3, 2, negative 6. Okay, if I multiply A by x, this is the matrix equation, and I need to know x. It's equal to B. And what is B? B is the answers. A is this matrix, اللي هي coefficient matrix, 1, 2, 3, negative 6 multiplied by x. I can just change it here to x and y because my variables are x and y in that order, equals to B, and B is 9 and 3. So how would you solve that if you have to use inverses to solve a matrix equation and anyways to solve the system of equations? So I want to get the inverse of A and take it over here. Get the inverse of A as if I want to divide by this and divide by that. Okay, so if I have A and 1 over A, something like that, I'm going to get rid of it. So the first step is to get inverse of A. How would we get inverse of A? 1 over the determinant, and the determinant here is negative 6 minus 6, negative 1 over 12. And then I will switch places, negative 6 and 1, and these two change signs. Okay, so the inverse is over here, negative 6 over negative 12 is half, negative 2 over negative 12 is 1 over 6, 1 over 4, and negative 1 over 12. Okay, so this is the inverse, here A negative 1. If I multiply the inverse by the answers, I'm gonna get xy. How? 1 over 2, 1 over 6, 1 over 4, negative 1 over 12 times, and not the opposite, because if I switch places I will not be able to get an answer. This is a 2 by 2 and this is a 2 by 1. I cannot put the 9 and 3 at the beginning. Okay, so I'm gonna get an answer that's a 2 by 1. Let's try row by column, and then row by column. I don't have my calculator with me. So anyways, this is the basic idea. I don't have, where's my calculator? I don't have my calculator. Okay, anyways, you know how to deal with this part. Anyways, you will get an answer over here and an answer over there, and this is going to be x and this is going to be y. For this part, I doubt. Anyways, you just know how to get inverses. The first part, how to find an inverse, and when does a matrix not have an inverse if the determinant is equal to 0. Know what's an identity matrix, and know this rule in case they bring the rule for Kramer's rule for 3 equations, and this rule, Kramer's rule for 2 by 2 two variables يعني, and how you get the determinant AD minus CB, and how you do this. I once saw it in your tests also, left minus right, how to get the determinant of a 3 by 3. And what else did I explain here? I explained how to multiply matrices. Mainly we saw together questions about multiplying, and I think barely one question will come in your test from matrices if there is. Okay, and operations, addition, subtraction, scalar multiplication was also in your tests. Thank you. Bye. By the way, I calculated it and the answer came to be 5 and 2 if you're trying. 9 over 2 plus 3 over 6, that's 4.5 plus 0.5, that's 5. And here 9 over 4 is 2.25 minus 3 over 12, which is 1 over 4, so 2. Okay, bye.